Hi, I'm Leif from Leif Labs, and I want to talk about the golden ratio and fivefold symmetry and how these things relate to each other. In order to do the things in this video, because of course all of these videos are about actually doing things, I'm going to ask that you do two things first. So go to my other video, which I'll have a link to in the description, to create the shape set. That's something that you can download and print out, and then you can make these shapes which are colored and laminated and which kind of contain geometric information. So you can follow that video and make all of these shapes, but ultimately for this, all we're going to want is these two shapes. Then the second thing that I'm going to say you should do is to watch Donald in Mathemagicland. This is an old Disney cartoon from, I think, the 1950s, starring Donald Duck, in which he goes into a world of mathematical magic and learns about a number of different mathematical things, but there's a lot of great geometry in there, in particular, an exploration of the golden ratio. So what is the golden ratio? There's a lot of different definitions. Some of them much more heavily rely on algebra and kind of geometric proofs and so on. But the way I think of it is the golden ratio is the ratio that describes how fivefold symmetry works in some sense. So the most basic shape with fivefold symmetry is a pentagon. So if I take a pentagon and I divide it up into its constituent components, I can make it out of these two kinds of triangles. And these are two of the shapes in the shape set. So I can use this shape to draw this. And so it's this way of... So what these two shapes do is they kind of tell you about how a pentagon works in some sense. So what we're doing in this exploration is we're kind of taking a pentagon apart and putting it back together in some sense, just like you would with some sort of machine you're trying to understand. You take it apart. So if I have this pentagon and I draw, there's really only two kinds of line segments I can draw between points. There's the ones that connect all of the points that make up the pentagon, and then there's the ones that go across like this. And the ratio between the long ones and the short ones, that's the golden ratio. So there, you hear a lot of different definitions of it, but to me, this is the most fundamental one because it comes from this fivefold symmetry that exists in nature. You can go out and if you see a cherry blossom, it'll have fivefold symmetry. And then you say, how does fivefold symmetry work? And you draw a pentagon. From the pentagon, you get the pentagram with these lines, and then that's where the golden ratio is. So now if I take this triangle and I take it at different angles, I can draw the rest of the pentagram here. And you'll see this. This is why I want you to watch Donald in Mathemagicland, because all of these kinds of constructions, if you do these constructions right after you've watched the video, then what you're going to see is that there's a whole sequence in the video that involves kind of taking the pentagram apart very quickly and putting it back together. And it makes for a great visual, but I think to really get it, to really kind of feel it in your bones, it is incredibly helpful to take this shape and go through and do this yourself. And so the way this shape works, to kind of clarify why I designed these the way they are, is that it's just the golden ratio repeated again and again and again. So the ratio of the long side of the short side is the golden ratio. And then from this short side to this, that's 1 over the golden ratio again. And then the next one is again over the golden ratio, so on, so on, so on, so on. So if I take the big pentagon, I draw a pentagram in it, that's the golden ratio. This line segment is the golden ratio bigger than this side. When I go down into the next pentagon, then this side is another factor down by the golden ratio. And so if I keep making smaller and smaller pentagons and pentagrams, what's going to happen is I'm just going to see the golden ratio again and again and again. And I can go the other way. If I want to, I can take the golden triangle, put it on one side of the pentagon and do this, and I can blow this back up into a 5-pointed star. And then that 5-pointed star, if you connected the end points, you would get another pentagon, and the pentagon would get bigger and bigger and bigger and bigger again and again by the golden ratio. So to me, the golden ratio is something we use to understand fivefold symmetry. And fivefold symmetry is a basic aspect of the universe that we encounter again and again and again in a variety of different places, both in nature and also in art. And so the actual construction that I propose to do here is you take these triangles. This is called the golden triangle. This is the opposite, where the golden ratio relates the shorter sides to the longer sides, where you've switched short for long. This is called the golden gnomon. And the two of these together can be used to make all kinds of patterns. So what I propose is you make a pattern, you color it in, and then you share that symbol. And the thing that's interesting and powerful about this is if you create a symbol and you do it using this triangle and you share that with somebody and they have the same triangle, then you should be able to replicate exactly this if you want. And then if you make a new symbol and you share it, then anyone else can replicate it. So it's a way to make beautiful, simple, self-replicating symbols that don't require some sort of artistic eye and the ability to very carefully copy things, as might be the case with some more complex art forms or so on. And so we're bridging kind of the gap here between art and math, where we're using the math of these triangles to create art, and then you can replicate that reliably by kind of the power of these shapes. So yeah, please make symbols, share the symbols, post them in the comments, and we can kind of continue to build a network, hopefully, of people creating symbols and sharing symbols. You could, in principle, there are a lot of symbols you can make very, very quickly with these that are different from one another. Once you start culling them in, the number becomes exponentially larger. So please join us and let's make more symbols. Thank you for listening.